This is a lecture on how to use divided differences to find the Lagrange polynomial, the polynomial of least degree that passes through a given set of points with distinct x coordinates. We will show how to construct the divided difference table and then use the entries from the divided difference table to find the formula for the polynomial function. First, we index and tabulate the coordinates of the points. While the points do not have to be written in any order, we will index the points from left to right, that is, with increasing x coordinates. This point will be a sub 0, and so with index I at 0, we have x sub 0 equals 0.66 and y sub 0 equals 0.896. This will be a sub 1, and so on. The next column in the table is for the slopes of the segments between consecutive points as we had indexed the points. We call this column f superscript 1 sub I. The superscript 1 indicates that this column is for the first set of divided differences. The first slope is for the segment between a sub 0 and a sub 1. The slope is equal to 8.07 minus 0.896 all over 1.88 minus 0.66. And this is approximately 5.8803. Repeat the exercise for these points to get the slope of this segment. And the slope is minus 3.061. We'll leave the calculation of the rest of the slopes, which we tabulate here, as an exercise for the viewer. There are other divided differences that we need to calculate and tabulate. But before doing so, we designate the y values of f as f superscript 0 sub I, even though these values are, strictly speaking, not obtained by taking differences and dividing. We label the next set of divided differences as f superscript 2 sub I. The entries of this new column are the slopes between slopes. Hence, the first entry for this new column of divided differences uses the difference of the first two slopes for the numerator. The numerator is minus 3.061 minus 5.8803. But what goes into the denominator is a bit more complicated. To figure this out, we draw a line from the missing entry to the y value to the left. This marks the start of the interval involved for this missing entry. It is the x value of 0.66 for the point that we need. To get the other x value, we proceed left and down diagonally to the y column. The y value that we hit marks the right endpoint for the missing entry. The x value, 3.52, is what we need. Hence, the denominator is 3.52 minus 0.66. So the first entry in this column is minus 3.1263. Let's try working out the second entry. We take the difference between these two slopes. So the numerator is minus 1.3067 minus 3.061, which becomes plus 3.061. Figure out the left x value. Then figure out the right x value. Hence, the denominator here is 5.02 minus 1.88. And the second entry in this column is 0.5587. Instead of working out the third entry of the column, Let's try working out the fourth entry. The viewer can try his or her hand at getting the third entry as an exercise. We take the difference between these two slopes, so the numerator is minus 4.9555 minus 2.8784. Figure out the left x value for the interval. Then figure out the right x value. Hence, the denominator here is 6.4 minus 5.02. And the entry is minus 5.6767. The third entry, by the way, is 1.8683. Let us work out the entries of the next column, f superscript 3 sub I. The first entry starts as before with the difference of two divided differences coming from the previous column. So we have 0.5587 minus 3.1263 or plus 3.1263. Then we find the left x value for the interval. In this case, it is 0.66. Then the right x value for the interval, and that is 5.02. So the denominator is 5.02 minus 0.66. The value of the first entry is 0.8542. We will work out the third entry of this column, and we will leave the computation of the second entry as an exercise. We use these divided differences for the numerator so that we have minus 5.6767 minus 1.8683. For the denominator, we seek the left x value, which is 3.52, and the right x value, which is 6.4. So the denominator is 6.4 minus 3.52. And the value of the entry is minus 2.6198. Let's review the process a little bit. To find this entry, we use two values from the previous column for the numerator. Then we obtain the x values by going horizontally to the left for the left x value, and then diagonally down to the y column. The right x value is the x value of the bottom y value. So if we write down a formula for f superscript r sub I, it is equal to the difference between the two previous divided differences as indicated by the superscript r minus 1, divided by x sub r plus I, which is the rightmost x value, minus x sub I, the leftmost x value. By the way, the second entry for this column is 0.3375. Let us now work on the fourth set of divided differences, f superscript 4 sub I. For the first entry, we take the difference between these two divided differences from the previous column. So we have 0.3375 minus 0.8452. Then we find the left x value for the interval. In this case, it is 0.66. Then the right x value for the interval, which is 5.76. So the denominator is 5.76 minus 0.66. And the value of this divided difference is minus 0.0995. For the next divided difference, which is the last one for this column, we use these two previous divided differences, so that the numerator is minus 2.6198 minus 0.3375. For the denominator, we have 6.4 minus 1.88. And the value is minus 0.6543. Finally, we have the last column, f superscript 5 sub I. There is only one entry, as the viewer might guess. The numerator is minus 0.6543 minus 0.0995, or we have plus 0.0995. The denominator has the right x value 6.4 minus the left x value 0.66. And the value is minus 0.0966. With a complete table of divided differences, we can now obtain different polynomials for any subset of consecutive points from the set. For example, the polynomial for the points for I equals 0 and I equals 1, the first 2 points, starts with the y value 0.896 at the left endpoint, followed by the first divided difference 5.8803 to the right on the table. And this divided difference is multiplied by the quantity x minus 0.66. which corresponds to the x value of the left endpoint. And of course, the graph of this function is the straight line through the 2 points. If we add the point for I equals 2, so that now we have 3 points, we start with the y value at I equals 0 as we had done before. Then the next divided difference, multiplied by x minus 0.66. This, of course, gives us the previous straight line. To include the point at I equals 2, we take the next divided difference of minus 3.1263, which we multiply by the quantity x minus 0.66 and the quantity x minus 1.88 from the first 2 points, but not the last point. The graph, if the 3 points are not collinear, should be that of a parabola. Before we work out another polynomial using a different set of points from the table, we'd like to point out that the number of divided differences that we use, and therefore the number of terms that show up in the polynomial, is equal to the number of points that we use. Let's do a variation on the problem. This time, we start the point at I equals 1 and go all the way to I equals 4. With 4 points, the polynomial should be of at most degree 3. Start with the y value 8.07 at the left point, followed by minus 3.061, multiplied by the quantity x minus 1.88, which corresponds to the left endpoint for this set. Then we have 0.5587, the next divided difference. This is multiplied by the quantity x minus 1.88 and x minus 3.52 from the first 2 points. Then we go to the next divided difference of 0.3375, which is multiplied by the quantity x minus 1.88, the quantity x minus 3.52, and the quantity x minus 5.02, which corresponds to I equals 1 to I equals 3, just short of I equals 4. And here is the graph. As a last exercise, let us find the polynomial for all the points from I equals 0 to I equals 5. Start with 0.896 at the left endpoint, followed by 5.8803, multiplied by the quantity x minus 0.66, followed by minus 3.1263, multiplied by the quantity x minus 0.66 times the quantity x minus 1.88, followed by 0.8452, multiplied by the quantity x minus 0.66 times the quantity x minus 1.88 times the quantity x minus 3.52, followed by minus 0.0995, multiplied by the quantity x minus 0.66 times x minus 1.88 times x minus 3.52 times x minus 5.02. And finally, we have minus 0.0966 multiplied by x minus 0.66 times x minus 1.88 times x minus 3.52 times x minus 5.02 and x minus 5.76. Observe that there is no factor of x minus 6.4 for the last point. And here is the graph of the polynomial.